everybody, welcome back boys and girls. It's your main math man, Ms. Shank, coming to you live from Alameda International High School. And in this video, we're still working with some review ideas, those trigonometric ratio identities. So make sure you can label your right triangle first. So again, we know that's a right triangle since it has that little square in the bottom corner. That's just saying it's going to be 90 degrees. So the first thing you want to do is we're going to draw that arrow opposite of that right angle to be able to say and label that's going to be your hypotenuse. So we're going to say, all right, we have one side already labeled. The missing angle that we're going to be working with today is going to be called theta. So again, it kind of looks like a zero, but it has that nice little line through it, so that way you know it is a Greek letter. So you have the side opposite of that angle theta is going to be called just opposite. So again, make sure that you're seeing those two differences. Again, the side across from the right angle is going to be your hypotenuse, and the side opposite of the angle theta is going to be called opposite. Last side that you have is your adjacent side, and that's just like this. You're going to say, all right, I have my side that is right next to my angle theta, or your neighbor side is going to be your adjacent side. And some of these trigonometric ratios are going to be like this. We have our sine function, so I can say the sine of theta. We're going to say it's going to be the opposite over the hypotenuse. Again, an easy way to remember these is like this. I can draw on the top right, I can say, all right, I have my acronym, SOHCAHTOA. That way it's an easy way to remember these ratios. So we're going to say, all right, we have the sine of theta is going to be the opposite over the hypotenuse. We're going to say cosine of theta is going to be equal to the adjacent side. The adjacent side over the hypotenuse as well. And we have the tangent, so we're going to say tangent of theta is going to be the opposite over to the adjacent. All right, so again, once you have those identities, make sure you can see in what I am referencing. So we're going to have our side labels, we have our ratio, and now we can plug in our values. So in that first example, it looks like this. We're saying, okay, I have my right angle. That means the side opposite of that right angle is going to be the hypotenuse. We have our angle theta as 45 degrees. The side opposite of that angle theta is going to be x. So we're going to say that x is going to be opposite, and that 7 centimeters is going to be our adjacent side. So again, you can just kind of label that first. Now we can choose our ratio that we want to use. So we are looking for this. We have opposite and adjacent. So we have opposite and adjacent. So we're going to use the tangent of theta. So again, I can write it like this. I have tangent of theta is equal to your opposite over your hypotenuse. Substitute in your values for your variables. So I have the tangent of 45 degrees is going to be equal to, well, what is our side opposite? That's just going to be x, and our adjacent side is 7 centimeters. Perform your inverse operations. Make sure you get that variable by itself. So we're going to multiply both sides by 7. So I have times 7 to both sides. Again, the reason why we're trying to do that, we're trying to get that x by itself. And so we're going to say 7 times tangent of 45 degrees is going to be equal to x. So again, in your calculator, make sure you're driving that car carefully. So we're going to say, all right, we have 7 times tangent of 45 degrees. Again, make sure your calculator's in degrees, and enter to get your wonderful value. So we're going to say, all right, this is going to be equal to 7. So we're going to say, all right, our side length that is opposite of that 45 degrees is going to be 7. So now go ahead, take a minute, pause the video, try this one out, label first what side is which, pick a ratio that you're going to use for this problem, and then solve for your missing side length. So now underneath of that, what happens now? So what happens when we don't know the angle? Well, it's just like solving any equation. We can use our inverse operations to isolate that variable. So for example, if we have that sine of theta, if we say, all right, well, if that's the opposite over the hypotenuse, maybe I need to solve for that angle theta. So how would I do that? Well, what's the inverse of sine? So you can write it like this. I would have to multiply both sides. So I'd have to multiply by the inverse. And what does that look like? Well, it's going to have a sine to the power of -1. So we're going to multiply both sides by the inverse function of sine. And so I have sine of theta. I have that's equal to, I have sine of to the -1 power, opposite over hypotenuse. And what does that look like in your calculator? So you're going to say, well, if I had, let's say, these two values, I had second, hit sine, and so you have that power to the -1, and so it's sine to inverse, and so we're going to say something like 5/7 would be an example like that. So you'll get your degree amount, and so make sure you're saying that that would be an example of 45 degrees. So same idea with the other trig functions. We have cosine of theta. That's going to be equal to adjacent over hypotenuse. Again, use your inverse operation, so I can multiply both sides by cosine to the power 1, or -1, excuse me. And I have times cosine to the -1 power. So again, that's just that inverse operation. Your cosines cancel out on the left, and so we're left with theta is equal to the inverse cosine adjacent over hypotenuse. So it's still going to be the same setup with your ratios. However, this is a completely different function, so be very careful when you are setting this up. And then lastly, we have tangent. So I have tangent of theta is going to be equal to the opposite over the adjacent. Inverse operations, I have tangent to the -1 power to both sides. And so you'd say theta is going to be equal to tangent to the -1 power, opposite over adjacent. So again, make sure you can take your time when you're evaluating these and you're solving for that missing angle theta, which is to the degree units. So then on the back, I have those wonderful pictures so that way you can kind of see what they look like. Again, when you're driving that calculator car, you're saying, all right, I press second to get that inverse trig function, and it should look like that. So again, I have those pictures in there, so make sure you are using them carefully. So for example, to solve for theta, be able to first label that triangle. Again, that side opposite of the right angle is your hypotenuse. We have our angle theta, and we're saying from that angle theta, across from it is going to be our side opposite. So we're going to say 4 is going to be our opposite side, which means 13 is going to be our adjacent side. And so what do we need here? Well, let's use those trig functions that we have. So I have opposite and adjacent, so I'm probably going to use that tangent function. So I can say it like this. I have my ratio. So I'm saying this, I'm saying tangent of theta, because we don't know what theta is. We have opposite over the adjacent. And then substitute in your values for your variables. So when I substitute, I have tangent, still theta, because we don't know theta. Our opposite side is 4, and our adjacent side is 13. Again, use those inverse operations. So I'm going to say, and take the inverse, so tangent to the -1 power, inverse of tangent to both sides. And so I'm going to say theta is going to be equal to inverse of tangent. And I still have 4 over 13. So in my calculator, I can type it like this. I have second tangent. I have 4 over 13. Can make sure you in degrees. And so we're going to say that's going to be equal to, again, round to that nearest whole degree. So I can just have 17 degrees. Be sure to circle your answer and make sure it makes sense. So I'm saying, okay, I should still have an angle that is less than 90 degrees since those angles are acute. And so that would check out. So same kind of setup for the your turn. Make sure you label it first. So again, label first. Get your ratio for this problem. Substitute and solve. All right, and then in the last example, it looks like this. Solve for theta. I have my labels. So I take my right angle, the side opposite of that right angle is going to be my hypotenuse, which is 11. I have my angle theta, which means the side opposite of that we can label as opposite, and that 4.1 is going to be our adjacent side. All right, so I have adjacent and I have hypotenuse. And so I can write it like this. I'm going to say, all right, what ratio am I going to use? Well, I can say this. I can say I have the cosine of theta is going to be the adjacent side, so adjacent over hypotenuse. Go ahead and substitute in your values for your variables. So I have cosine of theta. I have adjacent side, which is 4.4. I have the hypotenuse, which is 11. Use those inverse operations. So I have inverse of cosine to both sides, because whatever you do to one side, got to do the other side. So I have theta is going to be equal to, I have cosine inverse, and I have 4.14 over 11. So again, in your calculator, you can say second, and then I hit cosine. So I have the inverse of cosine, 4.4 over 11. Get your angle, and so we're going to say this is going to be equal to 66 degrees. Make sure that you can first label your sides of your right triangle. Make sure that you can set up your ratio first, substitute, and solve for your variable. Feel free to ask any questions at any point in time, and as always, super slam that subscribe button.